In this lesson, we're going to be talking about scientific notation. So by the end of the lesson, you should be able to identify what notation a number is in. You should be able to demonstrate how to convert numbers to scientific notation and demonstrate how to convert numbers to standard notation. So what is scientific notation? Well, it's a quick way to write really big or really small numbers. So to be in proper scientific notation, the number must be written with a number 1 through 9 and multiplied by the power of 10. So looking at the picture down here, our number in scientific notation is this one here. We have our coefficient as our number between 1 and 9, 4, definitely between 1 and 9, and then it's multiplied by the power of 10, which is what scientific notation is basically about. So if a penny contains about this huge number of atoms, then the average size of an atom is about 0.000000003 centimeters across. Well, working with numbers as big as this can be hard and cause us to make mistakes because it's so easy to happen. We can forget zeros, we can add too many zeros, or even put the decimal point in the wrong spot. So putting numbers in scientific notation stops many of these mistakes from happening. It gives us a smaller number to work with. We don't need as many zeros to talk about this big number, and it reduces the amount of mistakes. So if I wrote these numbers in scientific notation, they would be 2.0 times 10 to the 22nd and 3.0 times 10 to the negative 8th. Those were so much easier to say than those really big numbers. And putting these in some kind of problem would be a lot easier to write and a lot easier to handle than trying to write 12 zeros or 5 zeros and putting the decimal point between the right ones. So looking at these two scientific notation numbers, what do we notice about them? Well, first thing, is our coefficient between 1 and 9? Well, this one's 2, this one's 3. Yep, so the coefficient is in the right location. Okay. Are they both times 10? Looks like it. They both have a times 10 there. Okay. What about the exponents? What do we notice about the exponents? Well, if you look at it, the first number has a positive 22. So we're going to say that the first exponent is positive. If you're looking at the next one, well, you see that it's a negative 8. So the second exponent is negative. Well, what is the importance of having a positive and a negative exponent? Well, it tells you which direction to move your decimal. So if you have a positive exponent, that means you're going to move your decimal to the right. So with our first one, it was 2.0 times 10 to the 22nd. Well, we're going to move our decimal that way, which then gives us this number that'll be larger than 1. If our exponent is negative, that means we're going to move our decimal to the left. So this one, we're going to move our decimal that way, which then gives us a number that's smaller than 1. So how do we convert numbers to scientific notation? So if I'm giving you a standard number, like with these ones here, these are called numbers in standard notation. They are written as they should be. Then the first thing we need to do is find the location of the decimal point. So if you don't see it in the number, then you assume it's at the end. After we find the decimal point, then we need to move the decimal so that our numbers are between 1 and 9. We can't have a double digit coefficient. It needs to be a single digit 1 through 9. And as you're moving your decimal, make sure you count how far you moved your decimal point. So make sure if you move it 10 spaces, make sure you know you moved it 10 spaces. After you've moved your decimal point, add your times 10 and your exponent. Your exponent, this is going to be the amount of spaces you moved. So you moved it 10 spaces, well, your exponent is going to be 10. How do we determine if it's going to be positive or negative? So if we've moved our decimal to the left, then our exponent is going to be positive. If we move our decimal to the right, then our exponent is going to be negative. So let's look at this one. First thing, is this correct scientific notation? Is our coefficient between 1 through 9? No, it's 23. So our coefficient should look like that. Do we have our times 10? Yes, we do. Well, now that we've moved the decimal, we have to change the exponent because our exponent was based off of this. Our decimal point was here. I moved it one space over to the left. And remember, if I moved the decimal to the left, the exponent will be positive. So we're just going to add 1 to the 5, and our exponent's going to be 6. All right, so let's take a look at this one. The width of the universe is this really astronomically large number in miles. Where's our decimal point right now? Well, we know our decimal point is at the very end because we don't see it anywhere in this number. And where are we going to put our decimal point so that the number is 1 through 10? Well, to make it 1 through 10, it's going to have to be between the 2 and the 1, because if we put it after the 1, it's going to be 21. If we put it before the 2, it's going to be 0.21, which isn't between 1 through 10. So the only way we can do this is to put it right there. All right, so let's try this one. We've got to move our decimal place from here to here. All right, so as we move it, don't forget to count the spaces you've moved the decimal point. So let's do that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So how many decimal places did we move our decimal? Well, we moved it 23 spaces. So how are we going to write this? Well, first step, writing your coefficient. We've moved the decimal place so that the number is between 1 through 10. So let's write our number, which is 2.1. The next step, writing our times 10, then adding our coefficient. So this is why we count how many spaces we move our decimal point, because that number is our coefficient number. And remember, I said if you move the decimal place to the left, your decimal is going to be positive. If you move the decimal place to the left, your exponent is going to be positive. If you move it to the right, it's going to be negative. So in this problem, we moved our decimal point to the left, so that means we're going to have a positive 23. All right. Now let's try this one. So we have this number, and we want to know where we're going to move the decimal point to make the number 1 through 10. Well, our decimal starts right here, and we should move it right here to make it 1 through 10. Because if we put it before the 9, it's going to be below 1. If we put it after the 0 or after the 2, it's going to be above 10. So this is the best spot for it. All right, so now let's move our decimal point. Remember to count. 1, 2, 3, 4, 5, 6, 7, 8. So we moved a decimal point 8 spaces. Okay, so should our exponent be positive or negative? Again, remember, if we moved our decimal point to the left, it's going to be positive. If we moved it to the right, it's going to be negative. So in this situation, we moved our decimal point to the right. So that means we're going to have a negative exponent. So now let's write this out. Our coefficient, now with our moved decimal point, is 9.02. Remember to add your times 10 and then add your coefficient. Remember, we said it was going to be negative and we moved our decimal 8 spaces. So we're going to have a negative 8 there. Okay, let's try these. So first one, 28,750.9. Let's write this in scientific notation. First step, move our decimal point so that our number is between 1 and 10. So we should move it right here. So 1, 2, 3, 4. We moved it 4 spaces. And you can round these numbers so that you don't have to write this big, huge number. So we're going to write 2.9, add our times 10. Now add our exponent. Is it going to be positive or negative? We moved our exponent number we moved our decimal point to the left. So we're going to have a positive number, and we moved it 4 spaces. So it's going to be 2.9 times 10 to the 4th. All right, let's try the next one. Okay, again, need to make the number 1 through 10. That means putting the decimal point here. 1, 2, 3, 4. We moved it 4 spaces again. Write our coefficient, which is now 1.8. Add our times 10. Add our exponent. In this case, it's going to be negative because we moved it to the right. And we moved it 4 spaces, so it's a negative 4. And our new scientific notation number is 1.8 times 10 to the negative 4th. All right, so now would be the time, if you want to try these, to pause the video and come back when you're done. Otherwise, we're just going to keep moving through the rest of these examples. 61,400. We don't see the decimal point here, but we know that it's at the very end. Okay? To make the number 1 through 10, we have to move the decimal point between the 6 and the 1. All right, so now let's move it and count as we're moving. 1, 2, 3, 4. Another 4. Man, I did a lot of 4s in this one. So let's write our number, 6.14. Add our times 10. Add our exponent. We moved the decimal to the left, so we're going to have a positive exponent. 6.14 times 10 to the 4th. All right, try the next one. Need to move our decimal point so that the number is bigger than 1 and less than 10. So it's going after the 4. Let's move it and count. 1, 2, 3, 4, 5. We moved it 5 spots. Let's write our new coefficient. Add our times 10. And since we moved it to the right, it's going to be negative 5. All right, let's do the next one. We need to move our decimal point between the 2 8s. We're going to move it 1, 2, 3, 4 spots. So it's going to be 8.82. Add our times 10. Moved it to the right means it's going to be negative. So we've got a negative 4. All right, let's try this last one. Imaginary decimal point. Need to move it between the 3 and the 0 to make it 1 through 10. So let's do that. 1, 2, 3, 4, 5, 6, 7, 8. Okay, our new number is 3.06 times 10 to the 8th. Remember, it's positive because we moved it to the left. All right, so hopefully all this practice helped.